Sai, let us proceed. Yeah,
Yes, sir.
yeah. Go ahead. Go ahead.
Okay, so
Yeah.
hello everyone. Once again, on behalf of IETE Pune chapter, Buds Engineering Academy, and Civic Incubation Center, I welcome all the participants to our day 7 of our workshop on AI/ML for Internet of Things. During the last few sessions, we had a chance to hear from a lot of fantastic speakers who have shed their light on our topic, and they have also told us how to fit into the puzzles of AI, ML, and IoT. And their wisdom has definitely shared and expanded our knowledge, but has also left us with some immemorable insights. With that inspiration in mind, let's jump into today's session. And it gives me immense pleasure to introduce our first speaker for today, Dr. Sanskriti Shirale ma'am, who is currently working as assistant professor in computer department at Marathwada Mitra Mandal College of Engineering. She is a student centered professor with expertise in machine learning and computer vision, with great creativity, critical thinking, and problem solving skills needed to design solutions for real world problems. She has guided and developed various research projects from concept to completion in recent edge cutting technologies. So it's an honor to have you on board today, ma'am. I request you to please come upon the virtual dais and take over the session.
Thank you, Birds Academy. I have one humble request to Hule sir. In case if I got any query on YouTube platform, then kindly let me know, or you can put it in message box, because it is difficult for me to manage the YouTube and Google Meet simultaneously. Is
Yes,
it
ma'am.
fine,
Okay,
sir?
okay. Queries will, yeah, it will be in the chat box. Participants are requested to put their queries in the chat box. If necessary, we'll turn on microphone also. But you raise your queries in the chat box. Okay, go ahead, ma'am.
Yeah.
Thank you. Thank you.
Okay. 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 Thank you, sir. Thank you, ma'am. Just a minute. I'm sharing my presentation.
Yeah, yeah. Go ahead. Go ahead.
Okay. I think it's visible now.
Yeah, it's visible. Yeah, it's visible.
Yes, ma'am.
Oh, okay. I'm louder enough.
Yeah, yeah. Louder enough. Yeah, yeah.
Okay. Okay. Thank you. Okay, so good evening, all the dignitaries who are present here. You are welcome participants even. Your base for all these 7 days has been prepared for AI and ML for IoT workshop. So basic terminologies related to AI ML framework and IoT is cleared by all the experienced and eminent speakers. Today, I take this opportunity to brief you about the very important thing related to AI ML for IoT workshop, that is a data pre-processing. Before to start, I would like to introduce myself. I'm Dr. Sankirti Shiravale. I'm working as an associate professor at Marathwada Mitra Mandal's College of Engineering. My domain of expertise is about pattern recognition, machine learning, and data mining. So with this brief introduction about myself, I would like to continue with the today's contents. So this is the outline of my today's presentation. Understanding of data, data preprocessing, selection of ML models, IoT, ML architecture, then tiny ML, and last is the summary. So first of all, before starting to our actual, what do you mean by data? I would like to ask few questions related to what you know about a data, information, and knowledge. Because when you are trying to imbibe any kind of intelligence in any kind of system, it may be your normal desktop, it may be your mobile phone, or it may be any age for which you are looking for intelligence. So when we talk about intelligence, intelligence is nothing but we are trying to empower that particular device so that device will take the decision. So in short, intelligence is nothing but we are developing a capability in that device so that they will take the decision, device will take the decision. So my question to participants are, can anyone differentiate between data, information, and knowledge? Yes,
Yeah,
participants.
participants can put in the chat box.
Okay, because I got some instruction from host that session must be interactive. Therefore, I thought let us start with asking a questions. Otherwise, I will straight away go for the points. No issues. Okay, so let us start the presentation. So first of all, understanding of data. So a data is generating from various edge-cutting technologies like smart devices, IoT devices, smartphone, cameras, likewise. So the raw output which is getting or generating from these edge are known as a data. We cannot use or direct data is not useful for any decision making system. Hence, data is pre-processed or data is processed to get some knowledge. And once you get or once we get a meaningful content from that raw data, that meaningful contents are known as information. And if we use that information to take some kind of decisions for the business or for any kind, then that becomes knowledge. So you must understand, if you need to imbibe any kind of intelligence, then of course you need to convert that data to the knowledge. So this is nothing but how your decision making systems or how your intelligence work. For example, if we have a raw data, for example, birth date, from that birth date, you can process that birth date and you can derive a age, then that age becomes information. Now, if you use that age as an information to take some decision, for example, if you're a salesman, then you can analyze the age and you can decide that younger age people are more techno savvy, hence salesman or shopkeeper can target younger age people for their sales. In case of they are, if they are wish to sell mobile phones, laptops, or any gadgets. So this is how data becomes information, information becomes knowledge. And intelligence is nothing but we are applying that knowledge in decision making process. Another example related to IoT is nothing but suppose you have a one temperature sensor LM35 which produces analog data. So this is the raw data, raw output. We need to convert it into the digital values and then we are applying some threshold and then we are using that data to check the temperature of room. That is, the room temperature is normal, cool, or hot. So this is at every application when you are going to build ML or any intelligent till the knowledge, then only that is useful. So this is the generalized thing, that is a data information knowledge. Now, if you want to apply or if you want to play with data, then you must understand what are the different data types present in data. Data, either data analytics or in machine learning or in artificial intelligence. Because whenever you are going to apply any machine learning algorithm on the data, you all understand what is the data. So there are different data types. First is nominal, second is binary, third is numeric. Numeric is divided in two parts. One is called as an interval scale, other is called as a ratio scale. Other than these data types, machine learning algorithms may segregate these data in two more types. One is called as a discrete versus continuous. So we will see one by one what do you mean by nominal data. So nominal is also known as a categorical data, which has a fixed or infinite set of the attribute values. For example, if we take a hair color, then hair color can be black, blonde, brown, gray, likewise. So this is a finite set of hair color attribute. Then, for example, you can have zip codes and other things. Apart from nominal, we do have another data set called as a data type called as a binary. Binary is a special type of nominal data in which we accept only 0 or 1. That is either yes or no, true or false. Now, binary is subdivided into two more categories, that is symmetric binary or symmetric binary. In symmetric binary, both outcomes are equally important. For example, whenever you are filling a form and if your attribute is a gender, then equal importance is given for a male, female, and other. Okay, but this is not the case with the asymmetric binary. Asymmetric binary gives the unequal importance, means in case of disease prediction or any medical test analysis, a more weightage is given to positive. Means uh, in convention we assign one, that is a one binary value to most important outcome, that is a HIV positive or diabetes disease detected. So for S, we are assigning 1. So more importance is given to one of the variable value. So this comes into the asymmetric binary. Then third data type is called as a ordinal. Now, what do you mean by ordinal? Values have a meaningful order, but magnitude uh, between successive values is not known. For example, we are ranking the data. So we can have a grade of college professors in this way. There is assistant professor, associate professor, and professor. Otherwise, army ranking, cadre rate, then your normal ranking. So these all comes under ordinal data type. And we need to think whenever we are applying any machine learning algorithm, first of all, we need to think what data is available in my data set or which kind of data is generated by my IoT devices. Therefore, these things must be known to you before you actually start implementation of any ML algorithms. The next type of data is numerical data. These numerical data is divided in two more types. One is called as interval, other is called as a ratio. Now, interval values are measured on a scale of equal sized unit. So, for example, temperature in Celsius or Fahrenheit, then calendar dates. Important point to remember here is that these are no true 0 points. Means, for example, what do you mean by no true 0 points? I will explain it later once I explain ratio. When we talk about a ratio, it inherits the 0 point. Now 0 point terms comes twice over here, so I will explain it with one example. In ratio scale, we can speak of values as being an order of magnitude larger than the unit of measure. Means, for example, in ratio scale, we can apply any arithmetic operation directly. Means, if you take a temperature or if you take a length, now suppose at one instance length is equal to 5 and another instance length is equal to 10. So here you can directly say that length at instance 2 is double the length of instance first. So we can double it easily, but this is not the case of interval. If we take an example, that is a calendar dates, and suppose you are taking a year 2002, let us take a year as a 2002. And there is another instance where value of year is 2010. Okay, now here we cannot directly say that 2010 year is a 5 times previous year, because difference between 2002 and 2010 is 8 years. That is what it is said as a there is a no true 0 point. I hope you understood the concept, interval and ratio. In ratio, we can easily double it, we can calculate the mean, we can calculate the median, likewise. But in interval, it is not possible. So this is the numerical. Apart from, I will go to previous slide. Apart from nominal, binary, and numeric, most of the machine learning algorithms treat data only in two categories. One is called as a discrete and other is called as a continuous. Now, what do you mean by discrete? Discrete is nothing but, again, it is similar to nominal, where you have a finite set of values. Example is professional. Uh, then for profession, you can have a fixed finite set. Zip codes, you have a fixed finite set. Again, the hair color is again example. Now there is a interesting thing that I would like to tell here. Suppose I have one variable called as a age, okay, or another variable called as a height. In this variable, you are not supposed to judge that variable by their name, whether it goes with a discrete attribute or continuous attribute. You need to analyze what data is assigned to that discrete attribute or that continuous attribute. For example, if you say height, then height can have a finite set of values like short, tall. Getting my point? So height can be having short or tall. These are the values, or this is the set of values. Then if you have such a set of values, that height attribute goes under the category of valued attribute. And if height with the values, height can be 5.5, comma 4.6, means feet and inches. If somebody is putting that value, then the same height attribute goes under the category of continuous valued attribute. So you cannot judge attribute type depend upon their name. You can judge it only after analyzing what are the corresponding values present in that attribute. So this is really important to know discrete attributes and continuous value attribute, because whole your machine learning selection or algorithm selection is completely depend upon discrete attribute or continuous attribute. For example, if you take decision tree classifier, then for each value, one branch is getting out from the each node for the decision tree. So if there are, suppose you are taking a weight or height or age, then human age is starting from 1 year to suppose 100 years, then there may be possibility that there is a decision tree which can have 100 branches emerging from that single node. So to avoid such a time of such a computation, we need to apply some techniques so that we can convert that continuous attribute to the discrete valued attribute. Okay. So here the problem is that I'm not able to use my pen. I'm trying to use pen, but I'm not able to do. So sorry for inconvenience. Okay. So this is about the data. Important thing to remember is that you must analyze which kind of data is available in your data set before selection of any machine learning algorithm. Now, once you have a data which is generated by your IoT devices, it may be your simple numerical data, it may be a camera captured image, it can be anything. So that data you need to analyze first, you need to remember or analyze which data type is that. Once you gather a data, you need to check whether that data is appropriate to apply a machine learning algorithm or not. So in that way, there is one quote which is really important. If no quality data, no quality results. So now you have a data. Now you know what type of data is that. Now before applying, important factor is that you need to check the quality of data. And if you don't have that much quality, you will never get the results by machine learning algorithm. Because you might aware about during last 7 days you heard the same concept. You're feeding the data so that your machines can learn, and if you provide a wrong data, then obviously your machine will learn in wrong ways and it will not produce as expected results. Therefore, there is one more important step comes in between, means you are gathering a data and you are applying machine learning models. In between, this is a mandatory step. This is called as a data pre-processing. Now, what do you mean by data pre-processing? We are pre-processing the data, hence we are improving the quality of that data. Now, why there is a necessity of data pre-processing? Because data generated from IoT devices may be incomplete, noisy, inconsistent, and such a data is called as a raw data. And if you need to improve the accuracy of ML models, obviously we need to use a good quality or clean data. This is why we need to apply pre-processing. So this is the general flow of data pre-processing. You have a raw data, pre-process that data, and apply ML models. Now, what are the actual steps of data pre-processing? So these are the actual steps of data pre-processing. It is 4-step process. Remember, this is the means general framework of data pre-processing. First step is data cleaning. Second is called as a data integration. Third is called a data transformation. And fourth is called as a data reduction. Now we will see one by one. First is, or this is again the in-depth view of data pre-processing. First process is called as a data cleaning, where you have a raw data, you are cleaning and improving quality of that data. Second is called the integration. Why integration is important? Because a data from IoT devices, it is coming from different locations. It may be in different file formats. So before applying any model, obviously you need to bring it to the common platform, hence you can apply any machine learning model. So data integration is important one. After that, you are transforming that data as per your required format. Therefore, data transformation steps occur here. And last is called as a data reduction. Data reduction is nothing but you are reducing the volume of data, but still that data is that much powerful as original as it can produce the same quality results. So these are the 4 basic steps, and we are going to see one at a time. So as I mentioned, 4 step. First step is called as a data cleaning. Data cleaning is nothing but, if you look at the technical definition, it is nothing but you are handling missing value, removing noise, and handling or correcting inconsistencies. Now, why cleaning is required? Because data is incomplete. Now, why data is incomplete? Because sometimes while making a data entries, we may say NA or not applicable fields. Therefore, data may be incomplete. There may be human hardware software problems. Therefore, data can be incomplete. Then different consideration between the time when data was collected and when it is analyzed. So this is the huge gap why data is incomplete. Then data is noisy. So IoT devices are suffering from the noisy data. Why? Because this is generally generated due to the faulty data collection instruments, or human or error, computer error at data entry, or errors in data transmission. So most of the IoT applications are suffering with the data noise. Then third is called as a different data that may come from different data sources and may be due to functional dependency violation. As well as we can have a duplicate records that we need to take care. So this is why to clean or what is dirty data. Now, when you have that data, then you need to handle that. So I am again going to repeat the technical definition of data cleaning. It is the process of filling missing values, noise removal, and correct inconsistency. Data is not always available because for many tuples have no recorded values for several attributes such as customer income in sales data. We generally avoid to put such a kind of personal information while filling any form or while filling any kind of coupons. So why data is missing? Missing data may be due to equipment malfunctioning, inconsistency with other recorded data and thus deleted, data not entered due to misunderstanding. If sometimes data entry operator doesn't hear, then data may go blank. Certain data may not be considered important at the time of entry, not register history or changes of data. Therefore, data sometimes get misplaced. Now, how to handle a missing value? Means if in your data, if few records are null or there is a blank space, then we need to take care. So this is called as the handling of missing values. Now, how we can handle the missing values? There are few strategies. Either you can ignore the tuple. So if you feel that row or column is not important, then you can ignore that column or row. Okay. So this is a most popularly used strategy, that's the ignore tuple. But same time, we need to think how much null values are there. So out of 500, if 100 values are null, then at that time you are not supposed to ignore the tuple. You need to use different strategies. Second strategy is called as a fill in the missing values manually. So if you know that, suppose I am collecting a data of particular class, for example, second year class of computer engineering department, and suppose age field of that data is missing, then judgmentally I know that age of second year student is near about 20 years old. So blindly or depending upon my own judgment, I can feel that age value manually as equal to 20. So this is a feasible, means this is a simple solution, but not, it is very much tedious or infeasible. Then what is the third option? It is a fill in automatically. So how you are going to fill it automatically? So there are different ways. Either you can choose global constant. So directly if you are having a row, a particular row in which a particular value is, you don't feel that much important, then directly you can put that blank or replace that blank value with unknown, or you can label it with constant variable value. Otherwise, you can fill it with attribute mean. Now, suppose there is one salary column, and in that salary column, if particular value is missing. Now, in this case, it is not feasible that you can apply machine learning on blank salary value, right? So here you can take average of the salaries and you can fill that values. But what is the limitation? Suppose if you are having a payslip management system and you're having um, salary sheet which can have a salary of CEO, then other developers, and then peon also, then taking an average of all these salaries will mislead your result. Then what is the solution? So solution is that take the attribute mean for all samples belonging to the same class. So this is a smarter solution. Means if peon salary is missing, you can group by, you can apply a group by on peon, take an average and replace it with that. So this is the another simple strategy. Then last one is the you can fill that missing value with most probable values. Now how you are going to find out the most probable values? It is nothing but in simple way. You can apply some prediction technique and you can find out the most probable value using any prediction algorithm. For example, I can use linear regression, y is equal to mx plus c, where I can have a rest of the values and I can predict the most suitable value, or I can use Bayesian formula or decision tree. So this is how I am handling the missing values. Second is how to handle a noise. Noise is generally generated due to the random error or variance in measured variables. So incorrect attribute values may be due to faulty data collection instruments, data entry problems, data transmission problems, technology limitations, or inconsistency in naming convention. Other data problems which require data cleaning is duplicate records, incomplete data, inconsistency data. So let us see how to handle a noise. Noise is generally occur due to the transmission or due to the fault of instrumentation. So there are the strategies. Either you can use binning methods, or you can use regression, or you can use clusters and combine computer and human inception. So binning, in binning, we first of all sort the data, partition the data into equal size of binning, equal size of buckets called as the beans. Then we can use different technologies to smooth that particular bean. So there are different technologies called as smooth by bean means, smooth by bean median, smooth by bean boundaries. So these are the three techniques which comes under binning. Regression, clustering, these are the very famous algorithms, machine learning algorithms. You can use it for the noise removal. Then you can use combined computer and human inceptions. Means you can detect suspicious values and check by human. For example, again what we call it as an outlier. Suppose you are daily performing a transaction of your general habit of having a transaction near about 1,000 to 10,000. Then sometimes it may happen that you may have a transaction worth 1 lakh rupees. In that case, you get a bank alert from your bank saying that have you made the same transaction or not. So this is the confirmation call which you got. So this is generally depending upon your bank is looking for the outlier or some suspicious values, and if that suspicious or outlier get detected, then human check is done, and bank people call us and they just verify that transaction belongs to us or not. So this is the general procedure how you are removing a noise. Third point from data cleaning is called as a inconsistency creation. Sorry, correction. Now, inconsistency may be occur due to poor design or error in data entry or data decay. So data get vanishes over the time period called as a data decay, or uh, it data becomes data is not useful even, that is called as a considered as a data decay. Now why consistency inconsistency occurs? So for example, you can see a difference in data representation. In some cases we write a date format as a dd slash mm slash yy, or maybe we sometimes we consider it as a mm dd yy. So this is one of the type of data inconsistency. Now how to handle? So there are different techniques. You can use metadata, you can use domain knowledge, or there are specific tool called as scrubbing tools, audit tools, or you can apply some unique rules, null rules, consecutive rules to avoid the inconsistency. Then next is called as a data integration. So just to recall, I have ended with my first data pre-processing process, that or step called as a data cleaning. We are going to discuss data integration. Now, when we talk about a data integration, my data is collected from multiple resources and it may be in multiple format. So if my data is presented in multiple formats, how I can apply my machine learning algorithm? Therefore, integration plays an important role. For example, suppose I will take a very common example from my own college. Suppose I am belonging from computer engineering department. We are maintaining our student records using suppose SQL data set. And suppose other X department belonging to my college, if they are maintaining their student data into suppose Access or Excel or MongoDB, any other format. Let us take an example as a Excel. So now, being a means at office, suppose I want to make some analysis on my data. So here a problem comes is that computer department is putting data in using some DBMS systems called as a SQL, MySQL, okay, and some other department is using Excel. So how do I apply a common ML algorithm on these different data set? That is the problem. Therefore, it is important that we have to integrate the data. Now, how integration is happened? We can do it using schema integration. Every data or database is associated with term called as a metadata. Metadata says information related to data. So by accessing the metadata for each database, we can come that this particular column is meant for this purpose. Here you can see A dot customer ID is equal to B dot customer hash. Means how do I come to know that customer ID is storing the customer ID and customer hash is also storing the customer ID. Okay. So this information I will get from my metadata. So schemas can be integrated by observing metadata. Then sometimes a data is redundant. So that data can be analyzed using correlation analysis. Then there are few problems related to data integration. For example, detecting and resolving data value conflicts. Sometimes for some real world entity, attribute values from different sources are different. For example, different scales are there, different representations are there. Then means if you look at any shopping site, then their unit measures are different for USA, for UK. So if that variety of data comes, then how we can bring it to the common platform. So these are the few problems related to data integration. Next is data transformation. There are different techniques for data transformation. First is called as smoothing. This smoothing is same as we discussed in noise removal part of data cleaning. Next is called as a aggregation. Aggregation is nothing but we are summarizing that data or we can generating data cube. Means for example, you can look at this. We have a sales data for different year. We can apply some aggregate operations. When you talk about a database or any aggregation operations, then generally there are five major aggregation operations. First is called as a sum, mean, max, count. So these are the aggregate operations. So here you can see year-wise cells over here. So this is how you are transforming your data. Next is called as generalization, that is concept hierarchy climbing. I will come later on this point. This point is even equally important because if you have continuous value, then you do the discretization where we are using concept hierarchy building. So I will come later on this point. Other technique for data transformation is called as a normalization. Normalization is nothing but we are scaling that particular data into particular range. Now, what are the techniques of mean max normalization? There are three techniques: mean max normalization, Z-score, and normalization by decimal scaling. Other is called as a attribute feature construction. We can create a new attribute from the given data. Means, for example, from birth date, we can calculate age. So this is new feature construction. Now, I would like to tell why data transformation is required. So, due to time limit, I am going to explain only one technique called as a normalization. But here you will fully get convinced why data transformation is required. So, let us discuss normalization. Now, why transformation? Now, suppose there are two sensors. one sensor produces output value in between the range of 0 and 1. Suppose there is another sensor which produces output value in the range of 100. Before going exactly to this example, let us imagine that you and your friend. So, or you can consider two persons and you are comparing them on basis of two attributes. One attribute is called as a age, other is called as a income. Okay. Now age will comes in range of 1 to 100 and income may vary from 3-digit to 5-digit numbers. Okay. Now suppose if you are applying very basic algorithm, for example clustering, or if you want to find out the similarity between these two persons, or let us find how closer these two values or attributes with each other. Okay. And if you know the little bit about a Euclidean distance, where when you are putting a Euclidean distance to analyze how these two tuples are similar, then obviously my result of Euclidean distance will get influenced by income parameter. Why? Because income may comes in 5 digits and age may comes in 2-digit number. So my result will obviously get influenced by high range value. And if it is get influenced by high range value, then taking attributes are of no use. Hence, your ML may produce biased decision. So to avoid this biased decision of machine learning algorithm, we need to bring all the data on common, what I can say, not a platform, in common range. So you're applying that on the common range of 0 to 1 for age also and 0 to 1 for income also. The same example we will discuss here. We are, suppose when we are comparing two tuples, so T1 is a tuple which is having a sensor 1 value 5 and sensor 2 value 50 with other tuple which is having sensor 1 value 10 and sensor 2 value 40. Then when you're comparing using Euclidean distance measure, then result will get influenced due to the higher order values produced by sensor 2. Okay. So to minimize this effect or this biasness, we need transformation. And one of the transformation technique is called as a normalization. In normalization, we will discuss min-max normalization quickly. So suppose my income range is of $12K to 98K, then we need to normalize this to the range of 0 to 1. Now suppose there is input 73K, we need to map it into range of 0 to 1, then this is the formula by which we are doing the normalization. So what is that formula? V is the value which we need to convert minimum A, maximum A. So this is the minimum value 12K, maximum K is 98. Now new max range and new main range. This is the range in which you need to transform the data. So what is my maximum range? 1, because I need to normalize to 0 to 1. So maximum of 0 to 1 is 1, minimum is 0. So 1 minus 0 is 1. This will get nullified. Plus new mean. Again, new mean is what? 0. So when we put this value over here, then we got the conversion of 73,000 into 0.716. Okay. I hope you understood why transformation is required and how transformation is carried out. Next is called as a data reduction. Now, data reduction is nothing but we are reducing the volume of data, but yet it produces the same analytical results. So, how data reduction is achieved? Using data cube aggregation. Either you can have dimensionality reduction, where you are removing unimportant attributes, or you are using the compression, lossless compression, lossy compression. Then there is a numerosity reduction in which you are fitting whole data into some mathematical model. For example, if you have one column related to income and age, then that you can fit with a simple linear regression equation y is equal to mx plus c. Okay, so likewise you can fit that into one equation that is called as a numericity reduction. And last is called as a discretization and concept hierarchy generation. Now I will explain one from this called as a concept hierarchy generation. How this will help in reduction. Suppose in your data set, you have a states. Suppose there are these much distinct values present in state. Now I am building a concept hierarchy. This is called as a concept hierarchy. You can read it from the top down and bottom up. So you can build a concept hierarchy for your column. Stating means, let us take in this example, you can have a country, country can have states, states can have city, city can have street. Similarly, you can take an example of time dimension, then you can have a year, year can have a quarters, quarter can have months, months can have week, week can have days. Okay, so if you are climbing down in this hierarchy, you are getting the more detailed data. And if you are climbing up, means when we talk about the bottom up approach, then you are getting more abstract or brief view. This is called as generalization. When you are moving up, it gives you abstract or generalized view. If you go down, you will get more specific view. Now what it means, now you can see this much distinct values you will be getting reduced by cities. So how cities are there? 3,500 something. Okay, cities will be further comes into the state category. You may have 365 distinct value. So likewise, you are reducing your data representation from some lakhs to two-digit number. So this is one way of data discretization or reduction. This is the important one when you are handling numerous data. So concept hierarchy generation or discretization is really important. So we have discussed today data pre-processing steps. First is called as data cleaning, second is integration, third is transformation, and fourth is reduction. Once you have a data, this data pre-processing step, then you can say that good data preparation is key to producing a valid and reliable model. So you can say that your data is ready so that you can apply a machine learning algorithm. Now, these are the few tools that are used for data pre-processing. So these are, I have differentiated these tools into categories. One is called as the ETL tool, other is called as a data analytical tools. So what is the basic difference between ETL and data analytical tools? So these data analytical tools comes with the overall package of pre-processing plus your all machine learning algorithms. So you can apply any kind of machine learning algorithm directly using these analytical tools. And these ETL tools are specifically meant for data pre-processing, where it includes data cleaning, transformation, integration, reduction. So these are the some tools which you can use as a part of data pre-processing. And if you want to integrate with machine learning algorithms, then you can use analytical tools. So this is really important and crucial how you are selecting ML model. So first of all, you are selecting depending upon the nature of problem statement. You may get aware about this since last week you are attending the same thing. So I'm not focusing too much on nature of problem statement. You can select a supervised, unsupervised, either prediction or classification depend upon the problem statement. Then second is availability of data. This is really important one because if you want to use convolutional neural network or any complex models, then obviously they will perform well if you have a enough larger training data set. So that you need to check. Then again, important thing is that you need to understand the data. As I said, selection is completely depend upon how or what your data is there. For example, suppose you have a temperature column. In temperature column, you have a values in numeric 30 degrees Celsius, 40 degrees Celsius. Then this is going to be a problem of prediction. And if your temperature is having categorical values like a high, low, medium, or cool, likewise, then that problem statement becomes the problem of classification. So understanding availability of very much important when you are selecting a data. And last is availability of processing power. Because when you think about IoT, then most of the IoT frameworks, I will directly go to this slide because this is very much relevant to last point. Because whenever you are having any IoT architecture or framework, then you are gathering a huge amount of data and you're just processing or clubbing it and you're sending it over the cloud, where on cloud somewhere your ML models does the execution, do the analysis, and they send the result back. So this is the conventional way of your machine learning based IoT devices. Now the trend is slowly changing. Suppose you have very limited functionality of IoT device. Okay, then in that case, you're consuming more time on sending that particular data on the cloud and get the result back. Okay, so a trend is changing, that transforming, and now there is a research going on to put the ML models on that IoT device itself. Okay, because what are the limitations of this cloud-based architecture? Because latency, that is a delay, that is the first one. And as tremendous data is generated by these sensors, another is what? Bottleneck at cloud. Okay, so these are the main limitations occurring due to the increase, or what we are calling it as a big data. So you can see this second diagram. Sensors input is received by that IoT device. Basic processing is carried out. Data is sent on ML models, which are reside on cloud. Execution is carried out on cloud, and result is sent back over here. But nowadays, there is a tremendous research going on tiny ML. As I said, a drawback of cloud-based system is latency and bottleneck. So tiny ML is newly emerging research area where compressed and optimized machine learning models are installed, executed on IoT devices for better performance and cost effectiveness. So these are, if you're looking for the research, then you can think of this. How you are compressing your ML models and how you're increasing the hardware power so that they can execute on that machine or that device only. So this is the tiny ML. So I have a last 5 minutes. Quick summary. Tremendous data is generated by edge technologies like IoT devices, camera, phones, etc. Understanding and pre-processing of data improves the accuracy of ML models. Data cleaning, integration, transformation, and reduction are four major steps of data pre-processing. Availability of data, processing devices, nature of problem statement, and data insights are the key parameters for selection of ML models. TinyML framework in IoT is aimed to provide low latency, effective bandwidth utilization, strengthen data safety, enhance privacy, and reduce cost. So this is what we learned in today's session. These are the references. If you want to go inside in detail for data pre-processing, then you can refer the first book. There's a data mining by Hanan Camber. And for the TinyML, I have used this reference. So thank you. Thank you for giving me this opportunity.
Okay.
Now
Thanks.
question and answer.
Yeah. Participants, if you have any queries, you can put it in the chat box. If necessary, we can talk with the microphone also. Participants are requested to have a queries in the chat box. Yes, Abhinav. Dr. Nitin, yes. Kalpana, Vijaya. Yeah, any queries are there? You can put it here in the chat box. Sai, Shilpa, Smita, Suhas, any query? Yeah, Vijay is saying no, sir. Yeah, anyone? Swati? Yeah, Vijay is saying no. Okay. I think I'm very much thankful to Dr. Sanskriti ma'am. Session is self-explanatory, very nice.
Thank you.
Lecture was nice, Durgesh. So, yeah.
Though
So,
you feel any queries, then my email information is with sir. You
yeah.
can mail me.
Email
I
also,
will.
ma'am, as
Yeah.
discussed earlier, it is on the streaming. There also, you will find the entire session where you can put directly queries to ma'am also. So, on behalf of IET, yeah, it was more informative, Kalpana. Okay, very good. Yeah. So, IET Pune chapter, RBG's Birds Engineering Academy, Civic Incubation Center. So we are very much thankful to ma'am. Ma'am briefed us about the, actually it's a very big word. The data is a trillions and trillions of bits of data is generated, and the trillions of data, only having a data is it not enough. So from that data we have to utilize. So ma'am briefed about how to pre-process the data, how to aggregate the data, how to extract data, especially in terms of the data generated from IoT devices like cameras, the sensors. So huge data is being generated and how the data is being processed. So ma'am briefed about different algorithms. Ma'am has also given some tools also, those who are interested to further carry their research also. That's very much important. We'll go in detail again. And yeah, Dr. Nitin said something. Request ma'am guidance in case of queries. Okay. Uh,
Yes, yes, sure, sir.
Overall, it's a very wonderful section, ma'am.
Thank
Over
you.
to Sai now. Sai.
Yes, ma'am. So once again, a very heartfelt thank you, ma'am, for this enlightening session. It's your dedication to education and your invaluable contributions to the academic field is truly inspiring. And all the insights that you have shared with us today has certainly broadened our horizons, and we are immensely grateful for the knowledge you have shared here. So thank you so much, ma'am, for being with us.
Thank you so much. Thank you, Ghule sir, Birds Academy, for giving me this opportunity. I
Yeah.
hope the participants have enjoyed my session. And in case if required in future, I will be there for you, sir.
Okay. Thank you so much. Thank you, ma'am.
Thank you, sir.
Yeah. Next guest, Dr. Govind. I think he is in session. Dr. Govind.
Yes, sir. So moving on to the next session, it's an absolute honor to
Good,
introduce our next
good evening,
guest.
sir.
Yeah, yeah. Good evening. How are you? How are
I'm
you?
fine, sir.
Okay, okay. Yeah, you have told something softwares to be
Yes.
downloaded, so I have forwarded to the students also.
Okay, sir. Thank you, sir.
So I welcome you, but without wasting much time, just directly I will hand over to Sai. Sai, go ahead.
Yes,
Yes,
sir.
sir.
Yes, sir.
So once again, a virtual welcome to Dr. G. Prasad Acharya, sir, who is an
Thank you, ma'am.
accomplished associate professor and the associate head of department at Srinidhi Institute of Science and Technology, Hyderabad. Sir has an impressive academic background and a wealth of experience. Dr. Acharya has been a guiding light in the field of communication, machine learning, multi-core processors, architecture, and computer-aided design. So it's a pleasure to have you, sir. And I would request you to come upon the virtual dais and take over the session.
Thank you, ma'am. So, is my screen visible, ma'am?
Yeah, yeah, it's visible. Go ahead.
Okay. So, thank you, sir. Thank you, ma'am. And also thank the Buds Academy for inviting me for this lecture. So, good evening, all the participants and students. So today I'll be talking on the communication protocols in Internet of Things (IoT). So basically, like already we have so many sessions. So by this time you should have been aware of what is IoT. So just to brief, so IoT is basically a network of physical objects, and these objects they are like they can communicate with each other. They can sense the parameters of physical environment, and they can send to the other party. That means receiver or remote server, or even that these devices can interact with each other. So according to ITU, so International Telecommunication Union, so IoT is said to is a global infrastructure of information society. And there, like all the devices, whether they are physical or virtual devices, these devices are interconnected to each other. And the most important thing is here the interoperable. That means some devices may be operating with again, the different protocols. Like maybe some devices may be operating with the Wi-Fi, some devices may be operating with the cellular or whatever the means the number of devices will be operated with the different technologies and different protocols. Now here interoperable in the sense all these devices, even though they are operating with the different technologies or protocols, so they all can be able to communicate with each other. So that is what is called Internet of Things. So if you see in this picture here, this picture illustrates that so many devices, they can be connected to a global internet. So ultimately, the mode of communication is via the what I can say global internet. So that's why they are also called as the Internet of Things. Just a brief look here. So regarding the evaluation of IoT, so pre-internet, there is a pre-internet phase age. So where human to human communication is used to take place. So there we have fixed and mobile telephony, and we have the SMS. So after that we got the era of Internet of Content. So where we have all these human to human interaction. Plus, we have the smart network. So, smart network is nothing but like it's a network which can take a dynamic decision to forward the messages, to forward the packets. So, which particular path is to be followed? So, now basically, in a network or mesh type of network, so there will be a number of paths, number of nodes that can forward the data packets from your sender to the receiver. Now the network can take a decision to which particular path, through which particular path data is to be transmitted. So that means our network has become smarter. So that has given rise to the Internet of Content. So where we have like a www. So the application of this particular Internet of Content is email transfer, information, or even the entertainment. Now in the next stage, we got Internet of Services. So like we got all a Me Seva, E Seva, or I can say like e-commerce. So these are the the platforms which provide the services. So that's what now these the smart network, whatever we had here during the era of Internet of Content. So these networks are going to provide some smart services, some IT platforms. So that has given rise to Wave 2.0. It's basically e-productivity, e-commerce, Me-Seva, whatever, all those things. That means from internet we are getting some services. So then after that we got the smartphones, and as we know that. These smartphones can take like a, um, 3D, 4D, 5D, 6D. So these are the smartphones. So these smartphones can take like a 3D, 4D, 5D, 6D. So these are the smartphones. So it has given to internet of people. So where we have a number of social medias like Skype, Facebook, YouTube, Orkut, whatever it may be. So this particular era is called internet of people. Now after that, all the devices, all the objects or tags, whatever devices we are having at home, even normal devices are also becoming a smarter. Smarter in the sense they can transmit, they can transfer data on their own. So they can take their own intelligence is added to the devices, and which that has given rise to Internet of Things. So here we are having basically machine to machine communication. So it is from the age of human to human communication. The IoT has given a platform where a machine or an object can communicate with another object on another machine. So some of the applications here like identification, like tracking of objects. So monitoring, basically like you can say monitoring, industrial monitoring, what's happening in the industry. So what is the temperature level? So if whenever we are having some sort of like industrial applications, industrial unit where we need to measure the different physical parameters, all these parameters can be monitored automatically. So because of the devices and sensors, so all the sensors we can say, we can call them as smart devices. So sensors along with some capability with which they can transmit the data. That commonly we call it as smart devices. So this is the brief intro about the Internet of Things. Now after this Internet of Things, now the data with the inclusion of AI and ML. So our data itself has become smart. In the sense, by analyzing the data that has received through the smart devices or sensors, so we can analyze the data, we can take some conclusion, we can make the inference out of it. So based on that, so the ambient context. So that we call it like the next era of this next will be Internet of Everything, IoE. So this is the brief evolution of IoT, how the IoT technology have been evolved right from pre-internet age to the age of IoT. So basically, when we discuss about machine-to-machine communication, that is M2M. That means here the device or object can communicate with another object without any intervention from the human being. So that means in an example here is a data communication between things and server. So here we have the M2M device. That means the device that can transmit the data or that can receive the data by itself. So these devices have become autonomous. They have become the smart devices. So the smart instance, they can take their own decision on its own. Then we have like a M2M area network, like we are having the LAN, local area network, wide area network, like that. Here for this machine-to-machine communication, M2M, or against IoT. So we have something called connectivity. That means connectivity indicates the connection or communication between devices and the gateways. So gateways will connect these devices to the global internet. So that's it. M2M gateway is the interconnection to the device, interconnection between the devices and the global communication network. Then finally, we have communication networks. So communication between the gateway and the final end application. So application could be any sort of business processing engines, or like we can have any sort of like we are trying to get some data, like we have weather forecasting. So for weather forecasting, we need the data from the various locations. So data pertaining to temperature, humidity, wind flow, all those things. that will be required. So our ultimate application is the weather forecasting, or I can say now these sort of applications we can have. Now this is the generic block diagram of IoT, where we'll have the things, or things are nothing but it could be either sensors or actuators. Then we have the local network. So all these devices or sensors are connected to a local network. Then this local network, there is a gateway which connects this local network to the global internet. So there is a global internet over here. So gateway is the mediator between local network and the global what is the global network. And from global network, we can retrieve the data from the remote server, and where we can use we can run the various types of applications. So here we are accessing the user data, and even we can control the remote devices. All these sensors or actuators can be controlled remotely from this user application, from mobile devices or any sort of devices, or we can run any sort of business data analysis. So this is the generic block diagram of IoT devices. Might be all these things are already covered in the previous sessions, so I don't want to discuss much about this IoT. So these are the major elements of IoT. So you maybe you all know that IoT sensors. Then we have local processing unit or gateways, and then we have the communication technologies. Now I'll be focusing more on the connectivity or get communication technologies. So here all these technologies like Bluetooth, low energy BLE, or Z-Wave, or Zigbee, LoRa, Wi-Fi, and Sigfox. So using these are the technologies which provide low power wide area network. So we call it the LPWAN, low power wide area network. So we'll be using these technologies to connect all IoT devices. Because for our global internet, we have like a cellular system. Now, the major drawback of what existing internet is that they will consume more power. So each of these IoT devices, they can't offer that much of transmitting power. So that's the reason why we are going for the means there we have various technologies available which can offer the services with low power devices. Now these low power devices are, I can say, for low power transmission we have these technologies. And of course, these are the application sectors or domains of IoT. I don't want to discuss on this particular slide. Let us move to the next slide. Now, the terminologies that we come across when we are talking about the IoT connectivity, or I can say Internet of Things. So the way we are having the LAN in a physical network, physical internet protocol, internet. So here we call it the IoT LAN. So that means IoT LAN is nothing but it's a local short range which may cover a building or a small organization. So all the devices in a building or organization or in a short distance, short range, they are connected to this particular IoT LAN. The next we have IoT WAN. So where the what I can say the IoT devices which are available at the different geographical locations, they can be connected to the global internet through this WAN. So connection of various network segments organizationally and geographically wide which connects to the internet. Then we have the IoT node. IoT node is nothing but a device. Edge, sometimes we call it a sensor node or IoT node or edge device. So this is the we can say independent unit. So which can acquire the data through the various sensors, and that data can be transmitted to the WAN via gateway. Now these devices can be connected to the LAN, and then via gateway it may be connected to the WAN or internet, or the device can directly be connected to the WAN. Then we have the another entity that is called IoT gateway. So it's basically a gateway between a LAN and WAN, or LAN and internet. Then we have IoT proxy. So basically, whenever we are having some sort of like a firewalls kind of things, security, basically we use the proxy when we want to have a secured communication between two devices. So there we use the IoT proxy. So maybe there could be a firewall, so that will restrict certain devices, certain data from the certain devices which are authenticated. So data cannot be transmitted, cannot be received through an unauthorized or unauthenticated devices. So all that will be taken care by proxy. So it performs active application layer functionality between IoT nodes as well as the other entities. Then coming to the network configurations, we have like IoT LAN. Now multiple IoT LANs can be connected to a WAN. So there is a gateway. So these are the gateways. So gateways will connect all the nodes in a LAN to a central, I can say, working internet, global internet, or maybe may connect to another WAN. Now here we have something called LU. LU in the sense it's a locally unique. That means within this LAN, each of these devices should have unique address, unique identity. Whereas the device in another LAN can have same address, but these two nodes will be differentiated by its WAN address. So it's a unique locally. So if you take two different WANs or two different LANs, in two different LANs, the device may have the same identity, but whenever they are connected to a WAN or internet, the WAN address will differentiate these two nodes. So like here also we can have like a different network topologies, maybe star, have bus topology, star topology, mesh topology, all those things. So the way we are having it for our general internet, so we can have all those topologies. Now, so here IoT resulting in address crunch. That means now by 2018, so estimated number of smart devices was something around 20 to 50 billion. So by 2030, it is expected that number of IoT devices or number of smart devices would reach to 1000 billion. So that means I can say, if you take the human population on the earth, so it is something around 8 to 8.5 billions, whereas the number of connected devices, smart devices, and network devices, is much more than that. Because of that, even we have like there is something called IPv4 and IPv6. So basically IPv4, now whatever we are having the domain, we are using for IPv4, where we'll have it's a 32-bit IP address. So this is indicated like some dot no using dot notation. So 192.168.5.18. Now with this 32-bit address, we can provide unique addresses to 2 power 32 devices. So that comes around 4.3 billion addresses. So this 4.3 billion addresses, unique addresses, are not sufficient if we include the conventional network devices as well as the IoT devices. So that's why this IPv4 has been expanded to IPv6. So which provides a 128-bit IP address. So with this IPv6, I can provide unique addresses to 7.9 into 10 power 12 devices. So in the current scenario, or maybe for the next, at least for next 10 years, so IPv6 will work. That the address provided by unique address provided by IPv6 will be sufficient for all network devices. So that's why there is always now what is the result for the address crunching? Why number of addresses is falling short? So because all the devices, including the smart devices as well as existing devices, are to be connected to the internet. So because of the that means now because this we are falling short of addresses, IP addresses. So we have to upgrade to IPv6. Now apart from that, like even our cellular, Wi-Fi, Ethernet, these are the existing technologies. Now all these technologies, they are combined with, or we have integrated these technologies with the technology used for IoT devices. Like we have Bluetooth, BLE, DAS7, and IEEE 802.15.4. So these technologies, the technology communication technology used for IoT devices, they consume less power. Basically, low power, high range, long range. So that is the requirement of IoT devices. And these technology used for IoT devices are to be integrated with our Wi-Fi, what I can say, existing internet technologies. So because of that, there is that means we are having everything on a single platform. As a result, we are falling short of addresses. So that's the reason why we have been upgraded to IPv6 from IPv4. Now coming to the protocols. Now if I take a like IoT stack, now basically we are having the device management. So basically device management, now we have the numerous number of protocols based on the functionality. So one functionality is the device management. So these are the techniques, or I can say protocols used to monitor and maintain the connected objects. So that's why they come under the device management. So the IoT devices are to be connected. There should be communication between device to device, or I can say M to M, meaning machine to machine, and then machine to cloud, then machine to gateway. So for this particular part, we have the different protocols. And similarly, we have identification protocols. So where we have like each physical object in the world, whenever it is connected to the global internet, it is the unique device. It should have unique address, unique identity. So to have that unique identification, we have the different protocols. We need to follow the different protocols. Then we have the DNS messages, discovery messages, discovery protocols like physical web, mobile DNS, all these things. Then we have the communication protocols, low power, that's it, low power LPWAN, low power wide area network. So it could be like a Wi-Fi, Bluetooth, LPWAN, or we are having the LoRa, Sigfox. So a number of technologies are there available, communication technologies are available. Then come the next one is the data protocols. So data protocols means between how the data is being exchanged between the two devices. So there we have MQTT, COP, AMQP, XMPP. So our main focus here will be the data protocols. So in this, like in this particular lecture, I'll be talking about the MQTT, and I'll show you some. I'll give some hands-on sessions for this MQTT. If time permits, we'll be talking briefly about the other technologies, other protocol, data protocols, COP, AMQP, XMPP, and so on. So coming to the MQTT, so MQTT stands for Message Queue Telemetry Transport. So if I go back to the history, it was introduced in 1999, and this particular MQTT has been standardized by OSIS. That's in the year 2013. Sorry. And this MQTT is like a publish subscribe model. So in our regular internet, we use a TCP/IP protocol. So TCP/IP protocol is more or less like a request response model, whereas this MQTT is like a publish subscribe. That means I'll just show you here. We have some publisher. Now let's take the case of our weather forecasting system. So there we use a number of sensors, temperature sensors, humidity sensors, fire sensors, camera, all those things. So there is an agency which provides a what I can say, network of sensors, and we call that as a publisher. So that will publish, okay, that will send the data to a broker. So this publisher will send the messages on in the form of topics. Like a topic may contain topic A. Now in this case we have topic A and topic B. Now we have agency called broker. In fact, the broker will control everything, the communication between publisher and subscriber. The subscriber, in the sense, first what service you want to get, what's based on that, like now we have weather forecast system, and that particular application will register to the broker. So it has to first register, or I can say subscribe. What service? Now here this provides a service to so many sensors, so many data. So which particular data I need, or the my application needs. So that for that I need to subscribe. Now we have weather forecast system, we have fire detection room, and we have the intruder or surveillance system. So these are the applications. Now all these applications, they are to be enrolled, or can say subscribed to the broker. Now publisher will send the data to the broker. So there is a central unit which takes all the data from publisher, then to the corresponding subscriber. We are subscribed for a particular data. So it will deliver the data pertaining to that particular subscribed data. Now here the communication is in the form of topics. So in this case, now let's say subscribe 1 and 2. They have subscribed 1 is subscribed to topic A, whereas subscriber 2 has subscribed for topic A as well as topic B. Subscriber 3 has subscribed for topic B only. And this publisher will publish the data, will send the data to the broker. Now, based on the subscriptions, so broker will deliver the required, I can say, only subscribed topics. So this is what is the basic phenomena of MQTT. Now, for example, here we have three. There is a client, there is a responding client, there is a MQTT broker. Now, this requesting client is sending a data. Now, here we can say there is a topic. There is a topic here. The data that is being sent to the broker. Broker will send to the client, the responding client. Now, here information is just open the door, and that information, that data will be sent to the responding client, and the responding client is acknowledging back, saying that it has been succeeded, the door is open. So again, data is acknowledgement is going back here, the response topic, and it is indicating that it is done. So this is what is called MQTT. So MQTT. So it is designed to provide a connectivity. So basically, for embedded, or I can say IoT devices, the communication between the end application as well as the middlewares. It provides a connection between, there is a broker which connects your end device, or I can say IoT device, client or publishing device, to broker on one side, whereas on the other side it is connected to the receiving client. So we have the message broker, which controls the entire communication between publisher and subscriber, and all that, here the communication will happen between publisher, broker, and subscriber in the form of topic. So there is a topic to which a client is subscribed. It's updated in the form of messages and distributed by the message broker. So there's a device one, which is a publisher, or nothing but a sensor here. It is connected to the broker, and there is another client, or I can say another device, that has taken the subscription for the data received from device one. That means device two wants data to be received from device one. So for which device two has to subscribe to the broker. And once device two is subscribed, then the broker will receive the data from device one and will deliver to the device two. So device one publishes on a topic, whereas device two is subscribed to the same topic, and which device one is publishing, and then the broker is delivering the message or whatever the content to the device two. So device two receives the message. So this MQTT provides a simplest communication between multiple devices. And we have the constrained devices. In the sense, all IoT devices, they are constrained devices. That means constrained in the sense they will be operating, they will be consuming less power, they will be operating with less power. Normally, we have the battery operated devices. They will be transmitting only meaningful, some limited data, very small amount of data, low bandwidth. And these devices may also have very limited computational capability. So that's why we use a basic microcontroller boards like Arduino, or I can say Raspberry Pi, which has very limited computational capacity when compared to our GPU or general purpose processing systems, or so maybe CPU here. So that is how the MQTT works. Now here the communication between client as well as one means a publisher and subscriber is with the through topics. And yet the topic they are separated by a slash. So that may indicate the slash indicates the different hierarchy of messages. So we have the higher hierarchy home, oblique office, oblique lamp. Now here there's an MQTT client or you can say publisher that will publish data or the kind of status of lamp, whether it is on or off. Now I have to switch lamp. So I'll be giving a command, switch on the lamp, switch on the bulb. So the client is giving a command, is passing a command to switch on the device or to switch on the bulb through a microcontroller board. So here in this case we are having the Raspberry Pi. Then this particular client will be subscribed to the, now this particular device microcontroller will be acting like a client or like a broker, MQTT broker. And this client will be subscribed to the broker. So there is a channel, or I can say topic indicated here. That means whatever topic on which this client is publishing the data to the same channel or to the same topic, it has to subscribe. And once it is subscribed, and whenever this client is pushing the data, publishing the data to the broker will deliver that data to the client. So it is as simple as that one. So the client has to subscribe to the broker, and once it is subscribed, whatever data is received, that will be sent, that will be delivered to the client if the requesting data is of same topic or same channel. So we have a topic. It's a simple string that can have hierarchy levels which are separated by a slash. Like the example here, I have house, slash living room, slash temperature. So in a house, I want the temperature of a living room. So this is the hierarchy here. Even I can have like a house, another topic here, house, kitchen, temperature. Now we have here a wild card, that is a plus. That means this plus indicates all messages sent to this particular topic. And if you want to include the entire hierarchy, then we can use a wildcard, the hash as a symbol of wildcard. So there's a difference between plus and hash. So plus indicates that all devices of that particular hierarchy, whereas hash indicates all messages after in that particular hierarchy or in sub hierarchies, subtrees. So this is what is the MQTT. Now let us just have some sort of hands-on here. So I've already given an instruction. I passed a instruction here. You need to download this particular mosquito MQTT broker. So
Yeah, just how many have downloaded? You can put it in the chat box. Sir is having some interactive session. So
yes, how many have downloaded this particular software?
Yeah, yes, Mrunal has downloaded. Yeah, very good.
Yes, fine.
Zuhi has installed. Very good.
Right. So you can download it from this official website, mosquito.org. So once again there you can choose the version like the available for Windows or OS or Mac OS, all those things. So based on your device, You can select either Windows or Mac OS. Again, there also we have 64-bit version as well as 32-bit version. So that also based on your configuration of your device, you can install the corresponding file. So once it is downloaded and installed, you can check the configuration. I'll just show you here. And for that, just open the CMD command prompt. And there, instead of directly opening the command prompt, you run as an administrator. Now, just go to the location where that downloaded file is installed. So in my case, it is. Let me just go to that directory. CD program files.
Participants can put queries if you have any problem in downloading what sir is trying to say. You can put it in the chat box.
So any queries, any issues you are facing while downloading this?
They have downloaded mostly.
And you have to download and install it.
They have downloaded. Yeah,
it's a very like you can install it like any other softwares. So it doesn't require. Only the thing is you have to you should have the system administrator privilege. So with that you can download and install it. So I hope there are no issues while downloading and installing.
Sir, this program window is not visible.
Yes, I know, sir.
Yeah, okay. Yeah, now okay. Now
so
okay.
Yeah, to check whether it is properly downloaded or installed or not, so just go to your folder where you have go to the directory where you have installed it. So in my case, in my device, it is installed in C drive. There is a folder called program files. Within that, I have the Mosquito. Now, once you are there in this particular folder or in this particular directory, you can run a command that is called net start Mosquito. So this is a command you can, all of you can try parallelly and given the sufficient time. So net start Mosquito. So you may get a message for the first time. You will get a message called Mosquito broker services are started successfully. Now here already I will run this particular command here. So that's what the request service has been already started. Then you can also type another command net stat just to check the what I can say active connections. You can type the command here net stat space -e. So it shows the active connections show. Now here, as I told you, in MQTT, basically, now whatever I have done, this is through CLI, command line interface. You can also do it through a programming language that's a browser-based flow editing tool. We have the tool that's called Node-RED. So even you can do the program through this particular software, through this particular application here. So in the two ways we can do it. So we are going to have the same Mosquito MQTT broker. So that Mosquito MQTT broker can be configured either through command line interface or through this Node-RED programming. So this Node-RED program is a very simple program. It's basically like a flow editing. We have the input. We have in this palette. We have a number of palette sections. So there you can select a device, and then you can connect only. It's like a you can easily do it. But here I'm demonstrating through a command line interface. Now you what to the mosquito MQTT server, I need to, or can say one client has to subscribe and another client has to publish the data. Now first I'm going to subscribe here. So to subscribe, I've given the command here in PPT. It's there. The command is mosquito underscore sub hyphen t. Then we have test sensor data that's user defined here. So you can give any topic. In fact, it's a topic name. This is a topic name hyphen h. Then the local host. So you just copy this command. Again, run the same in your command line interface. Right. This is how we are subscribing to the mosquito or MQTT server. Now, similarly, I need to create another what I can say window, so through which I'll be publishing the data. So for that, again use another command line window. I have CMD run as administrator. And there also I have to go to the same directory. So I have CD program files. Then CD mosquito. Then I have to run a command to create what is this publisher. So I have this command here. In this command, there is a mosquito.pub. So let me just here. The command is mosquito underscore pub. So I'm going to configure the publisher with the same topic test underscore sensor data hyphen h localhost. Then the message that you want to send. So that's hyphen m. It's a message followed by whatever message you want to transmit. So let me just use this. So here the message is the temperature, which is or whose value is equal to 100. So you can transmit, you can send any message here. Need not be temperature. So let me just let me go to the publisher window. So I'm running this. Now let me keep both the windows side by side, so that in from one window I'll be transmitting, I'll be publishing, and in another window I'll be receiving the data. So this is my subscriber window and this is my publisher window. And what I'm what the publisher is transmitting, sending temp colon 100. That's a message. Now type this one and then click enter. So same that message temp 100 has been received at the subscriber window. Now you can transfer any data here. It need not be this temp like even hello. So whatever message your publisher is transmitting, your receiver will receive the same message. So this is the transmitter, or you can see this is the publisher, and this one is the subscriber. So I want everybody to practice this. So it's a very simple application. So where I need to have this mosquito broker. It's a what you can say MQTT broker. So in that I have to configure one subscriber and as well as I have to have one broker and publisher entity. So in between these two, there is a mosquito broker. So publisher will be publishing will be sending the data to the broker, and the broker will be delivering the data or delivering the topic to which the subscriber is subscribed. Now here, if I change the name of this topic, so here what I'll do is I'll change the topic name for which subscriber is not subscribed, and I'll change the message here, data 1. So with the message, I am transmitting the message, or I can say publisher is sending a message called IOT, but with the topic name test underscore sensor underscore data 1, for which your subscriber has not subscribed. And this data, this IOT, the subscriber is not receiving because subscriber has subscribed for a different topic, and publisher is transmitting the data through different topic. So there is a mismatch between the topic on which subscriber and the publisher are communicating. So that's the reason why I'm not, I can say the subscriber is not getting the message IOT. So that's why this is a simple protocol which will demonstrate this MQTT. So any doubts, any issues here?
You check your chat box.
If you have any
Krishna,
doubts,
is it possible to turn on microphone also? Participants can put in the chat box at the same time they can interact also.
maybe I think you have the privilege, no sir?
1 minute. Krishna, can you give the privilege to the participants to turn on?
Yes, I have turned on.
Participants can
They can
unmute yourself. You can interact if you have any queries. Yeah, go ahead, sir.
Does any doubts, participants?
Zui is saying
Sir, shall I
yeah.
proceed, sir?
Yeah, proceed.
Yeah. So this is about MQTT, and these are some real-time applications of MQTT. Even Facebook Messenger is using MQTT for online chat, and this Amazon IoT, they are also this AWS is using Amazon IoT with MQTT, and similarly Microsoft Azure, they use MQTT, and similarly we have everything IoT platform that also uses MQTT for the M2M communication. And this Adafruit is also using same MQTT protocol to communicate between the different connected devices. So these are some real-time applications of MQTT, and this MQTT is finding is the most popular, I can say, the protocol for IoT devices. So apart from this MQTT, we have some other protocols also. So before going to the next protocol, let me just have some reflection. So MQTT, the first one is MQTT is mainly used for what? So any answers from the participants?
Participants must
I
interact
want
with
the
the
answer
sir.
for this. MQTT is mainly used for what?
Zui has replied something. Suhas has replied something. Just see.
So answer is like M2M communication, machine to machine communication. Can you check whether they are correct or not, sir?
You
Because
see
I'm
the
in
chat box they are writing.
Because I'm in the full screen mode. Let me just come back to the here. Right. Now, next query is, or like next reflection is MQTT stands for or is dash oriented. It's a data oriented. Data means basically it's in the form of binary data, ones and zeros. Message, we can transmit any message or network or device. So through MQTT, we can transmit, or you can say the publisher can transmit a message. So it's a message oriented. So now we have the next SMQTT. It's called secured MQTT. So where we have this encryption, decryption. So it is very much similar to that of your, like we have HTTP and HTTPS, secured HTTP. So like that here also we have MQTT and its secured version is SMQTT. So where we have basically in this secret key and encryption, decryption, all those things. So here basically this particular protocol will have the 4 different stages. One is called the setup. So first a connection is to be set up between a publisher and the subscriber. Then the publisher will be transmitting the encrypted data. So along with the data, there could be like a publisher and as well as the subscriber may have some master key. So with the help of that key, the subscriber after receiving the data can decrypt the message. So this is the SMQTT. Now another important protocol for the constrained IoT devices is a COAP. It's a constrained application protocol. So it is very much similar to that of your HTTP, but it is used for IoT devices. So basic functionality of this COAP protocol is very much similar to HTTP. So it is again basically a request response model. So this is designed for M2M applications. So basically, whenever we are operating, we are using low power devices, and it is also used for the building automation. So basically, REST works on this particular, HTTP works on this REST interface. So it is the standard interface for HTTP client and server. Whereas a COAP is designed to enable low power sensors in IoT, where we'll be using a lightweight RESTful architecture or RESTful services. And this is the positioning here. Like we have the application layer, we have the transport layer, that's a UDP. So COAP basically it consists of request and messages. So this particular COAP layer lies in between application and UDP. So I don't want to discuss much about this. Now here we are having the different types of messages. One is a conformable message. Conformable message in the sense it provides a reliability. So client is transmitting some message, and server is acknowledging that that it has received the message. That is called conformable message. That means a client after transmitting the data will get a confirmation that whether server has received it or not. So that is called conformable message. And whereas in a conformable message, there is no acknowledgement. So the communication here of this conformable message will not have the reliability, whether it is delivered or not. Even that acknowledgement will not be sent back to the client. Then we have piggyback message. So in piggyback message, along with the acknowledgement, I'll be sending the message, which is piggybacked with the acknowledgement. Then we have the separate message where we'll have acknowledgement separate and data separate. So these two things, they are separated. So these are the 4 different types of messages. And these are core features. Now next one is, how much time is left? Time is over, na? Arjun sir.
Yes, sir. It is 8 p.m. now.
Yeah, 8 p.m. Just give me another 2 minutes. I'll just summarize. We have XML, or I can say XMPP, Extensible Message and Presence Protocol. It is based on this XML. So XML is for your what I can say, existing internet protocol. So the lightweight version of that XML is XMPP. So the next one is like AMQP. It is basically used for, again, it is ISO standard protocol, and it is basically used to have a communication, like what is business process or communication between two business organizations. So this again, this is similar to that of MQTT. So where we'll have the broker. So here also you have the broker here. There is a client, another client, or I can say transmitting client, or is a publishing client, and a consuming client. And only thing is here is there is a what something called queue. So advanced messaging queue. So there is a buffer, or I can say queue. So this broker can receive the data from the these publishers that can be pushed into a queue, and from that queue, the message will be delivered to the clients. So these are the certain things. Okay, because of shortage of time, I could not able to cover the remaining the other protocols in detail. So if you have any queries,
Participants can unmute themselves. They can speak. If they have any
you can,
queries,
in
they
fact,
can
you can
directly speak.
raise you can ask your questions if you at all, if you are having
Yeah,
any.
yeah. Yes, Zui, Suhas, Sai Pranit, Vijay, Kalpana. If you have any queries, you can go ahead. If you want to put it in the chat box, you can put it. Otherwise, you can unmute yourself and you can speak. Yes. Okay, Nikita, any query? Okay. I think they have done it properly. So first of all, no queries. Gagandeep is saying no queries. Nikita says no queries. Yeah.
So can I stop the presentation, sir?
Yes. Yeah. You can stop the presentation. Yeah, no issue. Yeah. So first of all, I'm very much thankful to Dr. Govind Prasad, as he has some plans for journey and all, but I have disturbed him for our benefits of our participants, and immediately he has accepted our invitation to interact with us. So on behalf of IETE Pune Center, RBG's Birds Engineering Academy, and Civic Incubation Center, we are too much thankful to Dr. Govind Prasad Acharya, and he has explained this IoTs in the communication protocols in excellent manner. He has introduced some hands-on directly the how to connect the windowing and how the devices are to be installed or connected, we can say. So further also he will be available. If you have any queries, you can put it further also. Once again, I am very much thankful on behalf of all to Dr. Govind. Over to Sai. Go ahead, Sai.
Yes, so once again, a formal, heartfelt thank you to Dr. G. Prasad Acharya for this enlightening session. We greatly appreciate your time and knowledge, which has enriched us in our understanding. So, thank you so much, sir, for being today.
Thank you, ma'am. Thank you, sir, for inviting me for to deliver a lecture. It's my privilege to be associated with you, sir. And I thank all the participants for listening my class, as well as they are having a long journey. I think it's a 1 month course.
Yeah,
Arjun
it's
sir,
1 month.
it's a 1 month course.
Yeah,
So I
1
think
month
it's only the second week.
Yeah,
So
this
they
is the
have
second week.
so they'll be getting the sessions from very eminent lecturers. So definitely all the participants will be benefited out of all these lectures. So if at all if you are having any queries, you can raise to me. So sir will provide my contact details. So thank you, Arjun sir. Thank you, Buds Academy, for giving this opportunity.
Okay, okay.
So thank you so much,
Okay.
everyone. We will end the session over here. Participants can leave the meeting, and we will meet tomorrow, same as usual at 6 p.m. Thank you so much, everyone.
So
Thank you.
participants are requested to follow the time. Our session will start sharp 6. So join us on the time. Try to get maximum benefits. Okay, thank you. You can end the session, say.